Today I'm going to tell you the most important things you need to know about energy for buildings. Obviously, the built environment is where we spend a lot of our time as humans, and the energy that we use in our buildings is very significant. So there's two aspects of the energy that goes into a building, or you can think about it also as the carbon emissions that result from our buildings. We have what is called the embodied carbon or the embodied energy, and this is the portion of the energy or the carbon emissions associated with the materials, the construction, the transportation, the things that go into building our buildings, building our built environment. And then there's the operational energy or the operational carbon emissions, and that really has to do with how we're using energy within the building. So this is our heating systems, our lighting systems, how we're charging our devices, that kind of stuff. And that operational carbon, as we're talking about it here, those carbon emissions can either be directly from the building or can be from the upstream electricity that is providing energy to the building. And so all of that comes into looking at the full life cycle of the carbon impact or the carbon emissions from a building. You will see that the operational energy in a building is a much bigger piece of the pie than the embodied energy. And if you think about that, that makes sense because the building lasts a long time. About 40% of global energy-related carbon emissions come from buildings. And a lot of that is coming from heat requirements in buildings. And that's heating for space heating, heating for water heating, heating for other things like cooking. So the heat requirements in our buildings is a big piece of the carbon emissions from our buildings in the operational part. And then there's obviously the embodied carbon parts, which are the materials like the steel and concrete and things that we use in our buildings. So we're still heavily reliant on fossil fuels, particularly natural gas, for meeting these energy needs within the buildings, in particular the heating bill in the buildings. And there's no slowdown in terms of our built environment happening. Global construction is set to double by 2060. And so we have a lot of buildings that are going in and buildings that are planned. And so that infrastructure is expected to continue to grow to meet growing demand for buildings. So if we're thinking about our building and trying to make it greener, the first thing we want to talk about is the envelope of the building and that embodied carbon. Yes, that embodied energy is only, less than a quarter of the overall life, but it still matters and it's still significant given how many buildings and how much building we do in the world. And so one of the things you can think about is what am I going to make my building out of? So concrete tends to be a very high embodied carbon material. Steel is the next most common material for our buildings, and especially for our big commercial buildings. Again, a pretty carbon intensive material, depending how you're making that steel. More and more, I would say for green buildings, wood is actually being looked at because it has a lowered embodied carbon, depending on a lot of factors on where you get that wood, but you're actually storing carbon by putting that in the building if you're getting it responsibly sourced or sustainably sourced. And there's a lot of innovations going on to try to make these materials more carbon friendly or lower carbon or maybe even zero carbon. And so there are ways, for example, that they're looking at changing the additives to concrete to lower the carbon intensity of concrete. I would say these are pretty early stages. They're not implemented broadly, but if we have the right incentives and policies, that these things could really take off and have an impact on our built environment. Let's talk about operational carbon. So if you were thinking about, okay, I want to make my building as green as possible, you would take the typical building. First, you would make it as efficient as possible. So you're lowering the energy needs in order to get the services you want. A lot of times these efficient buildings actually are also spaces that are more enjoyable to be in because they use a lot of natural lighting. Then you want to electrify your building. What you're doing there by electrification, those are additional efficiency measures, and you're taking air pollution sources out of your building. So when you're heating your water or your spaces with natural gas, you have air pollution actually in the building or being vented near the building where people are. And then once you've electrified it, you have a lot of zero carbon options, including on-site or off-site renewable energy to provide those services. To give you a sense of what services are we using in our buildings and what dominates, space heating is the biggest one. In some places, air conditioning might dominate, but if you're looking at average overall, these are numbers for the United States, but it would vary a lot globally. But in the United States, it's really the space heating and cooling are big pieces of both residential and commercial. And then you have things like water heating, ventilation, lighting, things like that, other services that we're providing. And you can see that the majority of this is still provided by fossil fuels. And in commercial buildings, about 40% of those services are provided by fossil fuels. And I don't want to forget that it's very different in terms of this operational energy and how it impacts households. And so, one of the big benefits of providing those services more efficiently, especially for low-income households, is that they already are bearing a pretty high energy burden on their household spending. In other words, a lot of times low-income housing tends to be more inefficient, both for the building and the space heating and the comfort, but also for the appliances and other things that they're using in their homes. And that leads to higher energy intensity for those services and a bigger portion, an outsized portion of their household budget goes to those energy services. And so electrification, building envelope, these kind of weatherization programs are really important, especially for our low income households, to really try to address this energy burden. So where do we look for efficiency in buildings? We usually start with orientation of the building. You know, you want north facing in places that are hot climates. You don't want a lot of windows on the south side. That's where you're going to get a lot of your heat loading. So orientation of the building, you look at all sorts of innovations on the envelope, high performance windows, insulation. A lot of these things can really lead to lower costs where you're lowering the sizing of your heating and cooling systems because you're putting that effort into the orientation and the insulation of the building. And I also like to talk about, you know, buildings are part of our communities, are part of our cities. They're not in isolation. So the location of the building can actually matter a lot when you're thinking about the holistic carbon intensity. So taking a net zero building that's beautiful and putting it out in the middle of nowhere and everybody has to drive there in order to go to work, that's not great when you're thinking about the whole system. So one of the things that we can think about is putting our workplaces or our homes along public transit corridors, for example, and really having the whole system in mind when you're thinking about having a net zero or a low carbon building. Building efficiency standards, and some of these have been codes and some of these have been guidelines, can really drive the efficiency of our buildings. And we've seen that success with like some of the ASHRAE energy efficiency standards and how they get adopted into building codes. So I wanted to talk to specifically about electrifying the building, but just looking at our space heating services, a lot of places are heated by natural gas furnace. Those can be 80 to 90% efficient. Sounds really great, but you do have that source of carbon emissions and air pollutions at your home. Other ways to heat a space, electric resistance heaters. This was popular in a lot of places in the Northeast, especially in like the buildings built in like the 70s, for example. That's actually 100% efficient. Like 100% of the electricity you're putting in there is coming out as heat. We can do that very efficiently. But what's even more efficient is a heat pump. And you've probably heard about heat pumps now. Europe has done a lot to build how many heat pumps they're putting in to try to reduce their dependence on natural gas. Heat pumps are even more efficient than 100%. They're 300 to 500% efficient. What that means is that for the electricity you're putting in, you're getting even more heat service out. And heat pumps do this because you're moving heat rather than creating it. And then if we want to make our building net zero, we have to think about providing that electricity with carbon-free resources. And then finally, I don't want to be remiss in talking about batteries because batteries can be a really important way to actually save money on a net zero building. So batteries do a few things for you at the commercial scale or at the residential scale. For the commercial scale, it peak load management. Commercial entities are often charged something called a demand charge, which is their monthly peak load during each month. And so this is like on top of the amount of energy they use, their peak power that they draw, they have to pay a demand charge. And those can be pretty high because the utility has to provide enough resources to meet that high peak every month, whatever that is. And so that's how commercial is paying for that peak. Batteries can allow them to really shave off that demand charge because Batteries can then be used to provide some of the energy during those peak times and really lower that peak monthly demand charge and can be really beneficial for commercial entities. And then for both residential and commercial, batteries are really great for shifting when you're charging and when you're discharging those batteries in terms of what are the costs of the electricity. So they allow you to purchase electricity when it's less expensive if you have time of use rates, and then sell it back to the utility when it's most valuable. Okay, I hope that gave you some ideas on how we can decarbonize our buildings. I highly recommend you head on over to our Learning Hub and watch the full lecture by Peter Rumsey, who has been working in this space for decades. And then, of course, if you just want to learn more about energy, I encourage you to join our Energy Spotlight.